Hello, everyone. I just finished grading your quiz, and I feel there's some confusions. And some people did well, okay? There are some people doing well, but not 100%. So I want to take this opportunity. I hope you will watch it and practice with me. So I'm gonna make this little recording. I try to keep it as short as possible, but I hope I can be more thorough and to maybe this will help you. Chain rule, how do we use chain rule? Okay. The solution to this is a written quiz number 6. Okay, written quiz number 6. The first question. So how do we do chain rule? All right. So you have your, I expect you to, when you watch this, you have your, index card with you, you have the formula with you. But when we actually use it, number one, you need to pay attention to the X, right? What do we differentiating with respect to? Okay, so I'm going to write it down. Differentiate with respect to. Okay. It's not always X. It's not always T, and it's not always theta. Okay, so sometimes it's with respect to X, sometimes it's with respect to T, and sometimes it's with respect to theta. So it could vary. So you have to pay attention to. You have to pay attention to the variable, but that variable typically will be expressed in the function expression. Okay. For that reason, that's why we like to use the German notation, which is dy dx, right? So in the case we're differentiating with respect to x. In this case, it's dy dx, right? So in this case, it will also be dy dx. But in this third question, it will be dy d theta. And in the fourth question, it will be dy d theta. And you have to honor that, okay? So this will be dy dt. So you have to pay attention to the variable that varies, okay? And how about the f? Right? So obviously in the first question, we don't have the y, right? Because in this question, nobody told us what y is. What you can do is you can put a capital F of x in the place of y. Okay? In the second case, you will use the lowercase f of x and put it in the place of y. If you want to introduce y, you have to introduce y. Okay, so I'm just showing you. And in the third question, you have dy d theta, and you don't need to make any change. And in this fourth question, dy d theta. And the last one is a capital F of t should be in the place of y. Then you may say, oh, I just want to use dy dx, dy d theta, dy dt, whatever you want. If that's the case, okay, give yourself a little convenience, it's okay. You can say, okay, I'm going to assign y equals to that. That way you can use either this notation or dy dx. But you would have to introduce that variable for yourself. And it would be true for the rest of it. If you want, but you have to make your context easy for the reader to read. Okay? All right, so that was about notation. Notation. So we need to pay attention to we're differentiating with respect to what? Right? So in the first question is with respect to x. The second question with respect to x. The third question with respect to theta. And the fourth one is with respect to theta. The last one is with respect to t. And if you look at the homework questions, they do have different variables with different names. It's to let us practice, to get familiar, so we don't get stuck with only one variable all the time. Okay? So now, so on this first question, I'm going to go over the first question first, right? All right. And since I did not introduce the capital Y, so I'm just going to remove this piece. Now, if you are going to use the composition, right? Some of you may not be very comfortable with the composition, so I'm going to first show you the composition method. So we see capital F of X as a composition of two functions. One, we call it F of X, lowercase. Okay, F of X. F of X, that will be equal to avoid confusion. Let me do U. Okay, let me do U. Okay, even though it doesn't make any difference, right? So I decide, remember in class, I talk about, we see the parentheses as blurry. So that blurry is U to the power 99. Okay, and our G function is just the blurry, the baloney, or U. So really, are you see from this step to the next step, we can tell obviously, if it's not obvious enough, that U is G. Okay, U is G. To make that more explicit, you write U equals to G of X. Okay, so now in order to complete our derivative, so after we have the U here, what you do next, okay, so we break down the steps. We're going to do F prime of U. Okay, for better notation, we are differentiating. Okay, so this notation will be differentiating F of U with respect to U for clarity. Okay, for clarity. And then you say, what's the difference between what we wanted, right? What is wanted? What is wanted? What is wanted is derivative of a capital F, which is here. Okay, so I'm going to just copy and paste here. This is what's wanted. Do you see there's a difference here? One is with respect to X, and the other one is with respect to U. Okay, so we're going to take a derivative with respect to U. So derivative with respect to U, and F of U is U to the power 99. So U to the power 99. And now we can use power rule, the derivative power rule. Okay, derivative power rule, what is it? Derivative of, in class, I used the Bologna. So here I'm gonna use Bologna. Okay, so it's hard because we're talking about power rule, right? Hard to the power of n equals to, so get your index card with you, okay, equals to n times hard. Okay, so we must honor the consistency. Hard to the power n minus 1. in your index card, okay, in your index card, all the place of heart is X. Okay, so now we change it to heart. And we change it to heart in all these three places. So if this is a heart, this is heart. That's what power rule says. Okay, if heart is X, heart is X, and this will be X. So now we're applying this formula, and we're gonna apply the formula, right? N is 99, right? So we get 99, and we don't have heart, we have U, right? So now U is the heart. You follow me? So this will be U raised to the power of 99 minus 1. Okay? Which is equals to 99 multiply U raised to the power of 98. Okay, so this part is done. Now, we're going to do du. Okay, we're going to do du dx. So this time, we're going to do du dx. Right? We have a u. Du dx, obviously, we're going to replace u by its equal. So u equals to this piece. So u will be replaced. We can write it down on the side like that. Okay, so please write down all these notations because these notations may be new to you. You need to practice. Okay, so this means that we're taking derivative of g with respect to x. Okay, so this is also called what? D prime. D prime of x. But we use a different notation, du dx. Du dx, because u is g, so derivative, g prime, that's what, these two are the same thing. And then we take derivative one by one, right? The derivative of sum is sum of derivative. The derivative one is 0, right? So what we're doing here, next step is that we're taking derivative on each one. On this piece, on that piece, and on that piece. And I see that all of you guys can do this without any problem, so I'm going to save some details. Right? The derivative of x is 1, and so this is going to be 2x. So that's how we get a 1 plus 2x. So now when we compose the final result, chain rule tells us the derivative of capital F of x with respect to x. We know this is different from that one. Okay, is a derivative of capital F of u. Okay, or lowercase f of u. Okay, I hope I don't confuse you here. Let's see. Because the capital F in relationship with u is the same relationship with the original relationship, except that we simplify the relationship. So see it as a simplify, right? I'm going to use a lowercase u, but in this case, so f of u, du multiply du dx. That's what you see on your index card, right? But you may on your index card you may have this capital F. The capital F is u to the capital F. If you write in terms of x, this is the relationship. If you capital F, if you write in relationship to u, okay, so let me just show you this, okay? So if I put a u And u is still 1 plus x, as we have shown here, is u to the power 99, right? So capital F of u is the lowercase f of u are the same thing in our situation, Okay, I hope I don't confuse anybody, otherwise ask me, okay? And next, what are we gonna do is I'm gonna take this piece, okay? I'm gonna take this piece and put it here. I'm gonna take this piece, multiply, that's what the chain rule tells us. Multiply here. You must have a parentheses. Even though we did not have parentheses here, you must attach a parentheses right here. But this is not done. So by this time, you're almost done. No more derivative need to be done. But you need to do the last step substitution. You need to do the last step substitution. And what is that last step substitution? The last step substitution, the last step substitution is you're going to replace the u by what u is in terms of x. So u is replaced. And then we are complete. Now we are done. So now the answer is such. Okay, so how much work do I need to see from you? I really don't need to see all of these. These are just an explanation. But if you express it, you really just need to go here. And once you understand these mechanism, once you understand the mechanism, okay, I'm going to show you another way to do it, which is more, a lot of things will be your mental. You will be mental, okay? So we want to take derivative like this. Okay, we know the chain rule is like this, right? This is the chain rule, right? This is the chain rule. This is the chain rule. So what's in our mind? What's in our mind? We are thinking of that. Okay, we're thinking of, let me put it down here. Okay. Remember the change from here to there, which is simplified version, right? So you're thinking I'm differentiating u to the power 99. In the classroom, I said you just think of the derivative of bologna to the power 99. The derivative of bologna to the power of 99. Let me see if I can find that star. Star, where is the star? I want to find a beautiful star for you. The bologna with respect to bologna. Okay? You divide it by bologna to the power 99. And here, of course, u is going to be your bologna. And with respect to x. Okay? So what I did here is that I'm telling you that this is the bologna. Okay? Derivative of bologna to the power 99 with respect to bologna. So in your head, you're thinking of this as bologna, bologna. You're differentiating it with respect to bologna. Okay, so you have that situation, okay, and you're differentiating with bologna, which is going to be, you forget about what bologna is. We're gonna come back to take care of bologna, okay? So this is gonna be 99 bologna to the power of 98. And as you're doing that, as you're thinking of that, you just put this in place. You should put this in place. So you think of this, okay? You think of it. You think of it as you're differentiating bologna to the power 99 with respect to bologna, which you get a 99. At the same time, you're applying that power rule, right? The power rule right here. Okay. And then we come back to take care of the bologna because we have to take care of the bologna. Bologna is what? In our compounds. It's obvious our bologna is right here. So our bologna is not neglected. And this part will give us 1 plus 2x. Okay. And then of course you have to replace bologna by it. So that's how it's been done. As you are getting better with this process. Okay. I hope that helps. Let's see what else. Okay, there's one more thing I'd like to explain. Okay, there's one more thing. There's a third way to see this, right? The third way to see this. Let me pause and I'm going to close the door. All right, I'm back. So the third way to see this is that we already reflected, right? On this is the chain rule. This is chain rule formula. Chain rule formula can also be seen, right? Because we're differentiating with respect to f, with respect to x. And capital F is a complex function, of x, right? So we basically break it into two pieces, which is a composition, right? And we know one piece, we see it as a bologna to the power 99. And then we take care of bologna, right? So this will be, so we break it into differentiating with respect to bologna. So divided by bologna. Okay, so let me still use that bologna. Do I have that bologna star with me? Okay, so this will be the bologna. You divide by bologna, multiply by bologna. But by differentiating with respect to bologna, we're differentiating a simpler function. We're differentiating a simpler function. And that's we do the simple part. And then we take care of the bologna part, if that helps. Okay, so once again, let's do it one more time. Okay, so we differentiate bologna to the power 99 with respect to bologna, which is going to be 99 bologna to the power 98. And then we differentiate bologna. We know bologna is 1 plus this parentheses. So we put that parenthesis in place. So we will get 1 plus 2x. And last but not least, we're going to substitute bologna in its original form. That's the chain rule. I don't know if this helps. Let me know if you have any questions. And I'm going to stop here. So make this video a little bit shorter. So these are the 3 different versions I have explained to you, and I will work on the other 2, and hopefully I will send it to you soon enough. So you do one piece at a time. Okay, so we do one piece at a time, and in the later time, I will explain in a similar manner. So we have 3 perspectives. One is after. So I hope one of the 3 will help you to get this, to understand and know how to do this. Okay.